again, I will post the notebook with all of the answers in it. Although there's not one right answer to everything necessarily, but I'll post it up there and you can go back and review or finish things that you haven't completed. Okay, for the last little part of class today, we're going to introduce plotting in Python. You've done a little bit of that in your last homework. We're going to introduce that a little more and build on that in subsequent classes. So one thing I want to get across to you here is that plots in Python or other sorts of programming languages and environments like R are really powerful compared to Excel especially. You have powerful plotting tools that are available for free if you know how to do some programming in Python and R. And we're going to get a taste of that today, and we're going to build on that before. These days, for publication quality plots, I don't use Excel, I don't use any of that. I think I get so much more power out of these. So if you learn to use these plotting tools, and it'll take more than just this course to really learn some of the tools, but if you learn them, it'll be great when it comes to publishing your papers. All right, so one thing we're going to learn about, well, we're just going to briefly introduce without explaining in any detail, is these magic commands. So you've used them a couple times when you've used plots. So these magic commands, I'm just going to highlight it in the middle of this long quote here, involve this % followed by various commands. So I'm just going to pull this from the documentation. They really are magic. You don't need to right now understand the magic underneath it, but I just want to explain the rationale, right? So, so the IPython kernel, basically the environment on which which runs the Python code in your IPython notebook here, it can display plots of the running code cells. So this takes a little special overhead here. So there's some special work that the authors of IPython did so that it would work seamlessly with this toolbox that we've mentioned, this package called matplot library. All right. So to set this up, you need to use this magic command. So this is a quote from the documentation here, right? And you've typed. Whoop, I keep doing that. You've typed this before in your assignments in your pre-class notebook. You type matplotlib, and then sometimes we use inline and all that. So here's really the key. This performs the necessary behind-the-scenes setup for IPython to work correctly hand-in-hand with matplotlib. Really, that's all I want you to take away from it right now. We may revisit this before, but the magic command in this case is to help this do a little behind-the-scenes work so that it shows you, so that these tools from matplotlib are usable. And another caveat here, as you'll see, and you saw this in the homework. The magic command by itself doesn't execute those import commands. Remember, we import pandas, we import whatever. We open the toolbox with the import command. So what you're going to see in the activity is you're going to use a magic command, and then you're going to use an import command to bring in some tools. Okay, very briefly here, let's just introduce a couple of data types, or plot types that we're going to explore. The first one is something you're familiar with. Extra slide, is histograms. And I'm just going to show you one version of a histogram from some of my own data. You work with histograms. Histograms show you one-dimensional data, essentially, right? You have one value here. What I'm showing you in this case, you can put, a little awkwardly, this is not the best way to do it, you can put two histograms on top of each other and compare them. You've often seen, and this one's a little rough, more often you'll see it smooth histograms. You can smooth out the jagged edges and you find it's like a histogram that way. So it's a way of showing one-dimensional data. The key part here is, so unlike a bar graph with some error bars which may show you values or pie charts that show you proportion, the data we're going to look at today is focused on distributions, right? So we want to know not just what, in the very first class you heard about summary statistics for distributions. We have something, you can summarize them with one value like a mean or with a variance. These plots we're going to look at today are a way of actually looking at your entire distribution. So that's the focus. So there are histograms. Another common type that you'll see, especially in genomic data, are box plots. And don't worry about the labels on these plots. And then, again, other stuff from, I just pulled a random box plot off my hard drive. Who's seen a box plot before, as opposed to a bar graph, right? So you're familiar with these. You've seen them before, right? One common mistake is to mistake these for bar graphs, right? These aren't error bars showing you the variance or the standard deviation or whatever. This is a histogram, basically. You take this histogram and sort of flip it on its side so that, in a sense, you're looking down on the histogram, and you can put several of them side by side. But, you know, we're not actually showing the full contours of a histogram. You got a middle bar that shows you the median. The edges of the box usually represent the 75th percentile and the 25th percentile, and then the whiskers at the end, depending on the program you use, sort of vary how far out they go. And then you have these little dots that will often show outliers. And this is nice because you can put several distributions next to each other and compare them. But of course you lose some information because you don't know exactly what's in these tails, but you roughly know the percentiles. So there's another way of showing one-dimensional data. So we want to learn how to make box plots. The final bit of data for showing distributions, but this time this is for two-dimensional data, and you want to see the relationship between distributions of two values for sets of items. You've seen these before, scatter plots, XY plots, and you can make them complicated. You can show, with different colors, you can show different data sets inside, and you can show them on a normal scale or a log scale. So all of these are things we want to be able to do in IPython. Just for reference, these are graphs I happen to create in R, but IPython gives you similar tools. Doing these in Excel would be painful there, especially with the scale of the data that we have here. All right, great. So that's that. That's it for the slides. Let's move over to activity 3. All right. And I'm going to see if we need to start this out together. So in activity 3, you're going to get basically now a brief introduction to these three different types of plots. Histograms, bar plots, scatter plots. They won't look particularly pretty at first, and in subsequent classes we're going to learn how to modify your plots and change the labels a little more to make them publication quality when you get there. But let's walk through this first part together here, the plots. So we're going to start out with one-dimensional histograms, and we're going to use this magic command, right? Matplot library, and inline. This command is necessary to show your graphs inline within your notebook as part of the output of your cell. So we enter that. It takes a moment to run. Actually, this is not running because I didn't do the top of the notebook. I'm sorry. There we go. Inline. Okay. All right. So you've used the magic command to get the kernel to get IPython to do its behind-the-scenes stuff to get ready to show these plots. Next, in the next step, now we're going to import tools from the matplot library, and you did this in homework 3 here. So let's take a look here. Right here at the commands you're going to execute here. We'll get you, and then you're off on your own. So we're going to import. This should be familiar from the pandas essentially. You're going to import this particular tool, pyplot. Using the dot notation, you can see it's part of the matplot library package, and we're going to give it a nickname. And so once that tool is, and this is all essentially from your homework. Once you have that tool, then you can use the functions in that tool. So right here we have a function that sets the plot styles. And so there is, we happen to use ggplot style. But you can check this out. You can add a cell here. If you want to look at the other styles you can use, you put a question mark after the function, hit Shift Enter, and it'll pop up this little, the documentation for this function here. Oh, okay. I thought I was going to show it to you here, but then you have to actually follow this this list and show you the styles. Okay, oh, there we go. I'm getting ahead of myself. Let's hang on here a second. So let's go ahead and execute these commands here in this cell. So I told you you're going to set the style. We're going to set these parameters that control the figure size to make your figures bigger, and go ahead and enter this in the cell and put it in there. And once you got it, we can look at the documentation for style. And so here we go. This is what I was going to do. It says if you want to look at the styles available, you need to enter the function cStyle available here. So we can type plot.style.available, and it gives us a list. See the brackets? Here's the list. So we chose ggplot. Later on in your homework, you can try other things you want. 538, Nate Silver's website there. I guess they have a plot style for that, and for others, and you can upload others. All right, so now we've loaded our plotting tools. Any questions at this point? Yeah.
So like, how can we know that the available command exists without like you talking? Like, if you do like plot that style, that value, like that it's used and available.
So the only reason I found out, so these are things you just have to pick up as you explore. The only reason I knew about it was because we tried this function, and I thought, well, let's see what's in this function, right? So I encourage you to do this. Put the question mark, look at the documentation for the function, and if we go down here, it tells you what goes into the function, and it says, for a list of available styles, see style available. But of course, we have to, you have to type plot style available to have the full dot notation, right? That was your name. So that's where it came from. That's a great question. Anything else? All right. You can go ahead and finish the activity now. We were going to make three plots. And already you'll see, you'll have the power to make these three different kinds of plots.